Okay, welcome to Lab 2, ADD Lib Boolean Functions. In this lab we will continue with the development of the binary decision diagrams. We will go through questions relating to the theory of BDDs, followed by reducing binary decision trees down to reduced ordered BDDs. We will also focus on combining multiple Boolean functions into a single BDD using Boolean algebraic operators. For this lab, we will use the ADD Lib Lab 2 Boolean function project in the ADD Lib where needed. So if you have the ADD Lib Lab 1 project folder open, you can close that project. We'll move on to the second one. So let's start with question 1. This is binary decision diagram theory. So if you watched the last set of videos from Lab 1, along with the links to the binary decision diagrams, these next 5 questions should be easy. And let's go through them briefly. What's the difference between a binary decision tree and a binary decision diagram? Well, if a decision tree, as we know, had branches, it had a high branch, low branch, or a true branch, a false branch. And binary simply means that when branching we only have 2 options, high and low. Now if there was 3 options available, then there would be 3 coming out of the trees. But in our case, it's binary, so we only have 2. So what was the difference between them? As we said, a binary decision diagram was more efficient. It required less space because it needed less nodes. It was faster because it was able to get to the terminals quicker, as it didn't need to go through unnecessary nodes. So there's a couple of the differences, but I want you to search up other differences and see what you can find. I'm not going to answer all the questions. Question 2. Does a BDD have to be ordered? As we said in the last set of slides or questions, that the BDD does not have to be ordered, but it is ideal if it is ordered. If it is ordered, you can get a canonical representation when reduced, and you will get the most efficient structure for your BDD. If they are unordered, there's potential for exponential growth in your nodes, which basically just means you're going to have an explosion of number of nodes and you'll still end up with the same result in the end. So it's just ideal to have an ordering and stick to that ordering. Is an ordered BDD or BDD the same as reduced order BDD? And the answer is no. Simply an order BDD, as we said before, you have a set ordering from top to bottom with specific nodes following a previous node. However, that does not mean that has been reduced. You may not have applied all the reduction operations in these 3 operations. You may only applied 1 or 2 of the 3 operations, so not have been fully reduced just yet. Therefore, it is simply an ordered BDD. So that it would be the difference. And name the 3 operations required to produce an ORO BDD from a decision tree. Again, we went through this in the previous videos, but just quickly, they are you merge the equivalent leaves, or as we've been calling them, terminals. So if you have multiple trues and false, or zeros and ones, you just create 2. Just merge the equivalent leaves, and then you reroute all the incoming connections to your new leaves. 2. You merge isomorphic nodes. So when 2 parent variables go to the same child node with the same high and low pointer, then you can merge these nodes. And 3, eliminate redundant tests. So if x goes to y and both of y pointers both go, the high pointer and low pointer both go to false, then you don't need y. X can just go straight down to false. So y is redundant, so you can eliminate it. There are the three operations. See the last set of videos and the videos online for more detailed explanation. What are the main advantages of an ROBDD over decision tree? And again, this could go back to what is the difference between them. Basically, it is more efficient, requires less memory, it is fast, and it is faster getting to a result. The worst case scenario of an ROBDD in speed would actually be the fastest for a decision tree. Because in a decision tree, you're going to have to go through every single node to get down to the redundant leaf. And that would only happen in the ROBDD in the worst case scenario. If even. And that is question 1.